Hi everyone. In today's challenge, we have this problem swapping nodes in a linked list, and the problem number is 1721. Alright, guys. So first of all, we are going to clearly understand what this problem says. After that, we are going to move to the logic part. We are going to see the brute force approach, optimize approach, and after that, we are going to move to the implementation part. We are going to implement our logic in C++, Java, and Python programming language. And if you want to see the implementation in your programming language only, then you can move to that particular part. I have mentioned the timeline as well, right? Now, guys, let's see what this problem says. So this says you are given the head of a linked list, an integer k. So one thing is clear that we are given two things, head and k, right? Head is the head of a linked list and k is the integer value, right? Now what we have to do, we have to return the head of a linked list after swapping the values of kth node from the beginning and kth node from the end. So it is a very clear, right? One line statement. So it says that, guys, first of all, we are given the linked list. Let's say this is a linked list, right? So I'm going to say this is a head, which is nothing but a one, right? So this is a linked list we are given with. Now we are given the k is equal to 2, right? So what we have to do, we have to find this second, here it has given kth node from the beginning, right? So we have to find the second node from the beginning, which is nothing but this one, and kth node from the end. So kth node means second node from the end, that is nothing but 4, right? You can see this is 0 and 1, this is second node, and this is from end, this is first node, this is second node. So we have found the beginning node and the end kth node. Now what we have to do, we have to just swap this. So 2 will come here, 4 will come here. So we can say 2 is going to come here and 4 is going to come here. So this is the problem. What after doing this thing, we again return upper linked list. So which is nothing but head only, right? We can return this particular thing. So I hope now you understood the problem. So now it's benefit to go to the logic part once you understood the problem. If you still have any kind of doubt in the understanding of this problem, then you can write in the comment section, right? So now let's see the logic part, how we can solve this particular problem. So guys, let's see the logic now. And before moving to the actual optimized logic, let's see the brute force. If you will come up with the brute force, definitely you can come up with the optimized, right? So try to come with the brute force approach. Are you getting any brute force? Don't think about the complexity or space complexity, anything. Just think about the approach. Can you solve this particular problem? Don't think about the complexity. Again, I'm telling you. It can take a n square, n cube, 2 raised to power anything. But can you solve this problem? Let me tell you one brute force approach which I'm getting right now. What I can do, I can say that first of all, I can find in one step I can find a length. So I can say n is equal to something which I'm going to find the length of this linked list, which is going to take a big of n. Then second step, what I can do, I can say I can store this linked list. So this is linked list, right? 1, 2, then 3, then 4, then 5. This is linked list we have. So I'm going to store in an array 1, 2, 3, 4, and 5, right? So I have stored in an array which is going to cost me big of n, right? And why I have find out the length, because I want to make a static array, right? After that, in third step, what I can do, I can swap this value, right? The second index and the last second index. So I can swap this. It will become 1, 4, 3, 2, and 5. I have this is clear. So it is going to take big of n, right? Now let me scroll it because I know this is not visible to you. Now what I can do, I can say in fourth step, again convert this into linked list. 1, then 4, then 3, then 2, then 5. And I'm going to return this particular linked list. So it is also going to cost big of n, and this will going to cost big of n. Swapping will take only constant time. Fine. So this is the brute force approach, right? And can you tell me the time complexity and space complexity of this brute force approach? Just think about this. It is simple. Time complexity will be 3 times we have taken a big of n. So we can say big of 3n plus 1 because 1 is constant. And asymptotically, it is going to be big of n, right? And space complexity is nothing but big of n. I hope you have already seen that we have created one array, isn't it? So it is going to cost us big of n. So this is the brute force approach. We can solve this particular problem in big of n time complexity and big of n space complexity, right? Now, can we do better? Can we solve in a better than big of n time complexity? For now, I'm not able to come up with an approach which can solve in better time of big of n. The optimized approach is also going to take a big of n time complexity, but it will remove this parallel big of n. Means it is not going to take big of 3n plus 1. It will only take big of n, right? And space complexity definitely we can reduce. We can say big of 1 in optimized, right? So brute force approach, I'm not going to code because you can easily code these things, right? It is not going to take a like hard thing, or we can say a complex loops or functions, right? So this you can do. Let's see the optimized approach. Then we are going to code the optimized one, right? So what is the optimized approach? So guys, I'm going to again draw the linked list 1, 2, 3, 4, and 5. So this is our linked list. So I can say this is linked list. Head is given us and key is 2, right? So what are we going to do? And before that, guys, I will recommend one questions on a Leetcode. This is remove kth. Let me write in different colors so that you can have better understanding. Remove kth node from the end of the linked list. You can find write this thing on a we can say browser and search on a Leetcode. It will definitely available, right? So remove kth node from the end of a linked list. If you have solved this particular problem, then you can definitely solve this problem. You don't need to watch this any video. You can definitely solve just because these two questions are parallel, right? Both have same logic. Either you can solve this problem and after then move to this particular problem, you can solve this problem easily. Otherwise, you can start from there and come to this. I will recommend first solve this problem, then come to this particular problem, right? Fine. So now we have given, let's move to the logic. So we have given with this linked list. And what we are going to do, we are going to say, just find the beginning kth node first. So this is 0 node. We can say this is first node, second node, third node, fourth node, this is fifth node, right? This is the actual value and this is the order, like on what position they are standing, right? Fine. Now we are going to find the first kth node, which we can find like by this. We can say make a current pointer which is pointing to head. We have made a current pointer which is pointing to head, and we can use a loop, right? We can easily do this. We can find easily the beginning kth node, right, by using a loop. So we can say for starting from 1 to k, just keep iterating, and current should be equal to current dot next. What it will do, whenever this loop will end, it will be available at the kth node, right? So here current will be current equal to next. Fine. So we have find this particular node, and we can say our current is standing over here. So let me do this. So current come here. We have find this beginning kth node by using a simple loop. Now the tricky part is how we can find the end kth node from the end, right? Kth node from the end. So which should be like this, right? So how we can find this? We can find by using this current pointer only. Now what we can do, we can once we reach to this, we can store it on let's say any pointer which is first node. If you know C++, then you can use a pointer. Otherwise, in Python or Java, we can simply store like this, right? First node should be equal to this current. I given a variable name first node, which is storing now this particular node. Okay. Now means we can forget about this thing because we have already stored somewhere. Now what I'm going to do, I'm going to initialize a new variable that is nothing but a new current. I hope you are getting this new current, which is nothing but here only, right? Now what I'm going to do, I'm going to iterate this. I'm going to say iterate. Here I can write a condition while current is not current of next is not equal to null. While current of next is not equal to null, what you can do, you can keep iterating and make current is equal to current next and new current is equal to new current next. What this will do one thing that it will be its next will be null only when the distance between let's say you know that, let me make it a little easy for you. Let's say guys, this current is gonna be come here, right? So if I just iterate this here, current is here and new current is here. It will gonna move iterate, current is here, new current is here. It will gonna move iterate, current is here, new current is here, right? Now current next is null, right? When current next is null, you can see the new current is standing at the second position. Why? Because distance between them is gonna remain same, and here we know that distance between them was 1, right? And here also it is 1. So we know that this is standing at second position, this is at the first position. So at the end also this will be standing at the -1, means the last first position, and this will be standing last second position. Does that make sense? So this is the benefit. We have initialized a new current which is pointed to head, and we keep iterating until the currents next should not be equal to the null, right? So this will give us the last second or last kth node, right? Whatever the kth node we have. So once this loop will over, we will having a new current which is pointing to this one. So I can say current was this one, but we have forget this. So current will be become here, and the new current will be here, right? So new current is here, and first node we have already stored this particular thing too. So we can swap them now. So now let me show you how we can do this. We can say new current is here. New current will be at the end, and first node we have stored that having a value nothing but 2, right? So now what we can do, we can swap them. We can swap their value. We can say this dot value and this dot value should be swapped, and we can use the swap function. We can use inbuilt swap, right? So once we are done, we can return the same head. So this is going to do nothing but big of n. Why? You can see this loop is going to iterating k time big of k, right? And this loop is also while loop is going to iterate k time, not k. I would say n minus k time, right? So n minus k plus k is going to be nothing but big of n. So it's going to take a big of n operation. We can see in term of time complexity. And in space complexity, we have used a two variable, right? First is current, second is first node, third is new current. So we have used a three variable, which is nothing but space complexity give us big of n, right? Big of 3 is nothing but, let me write a big of 3, which is nothing but big of 1 only in asymptotically term, right? So once we have done this thing, that means we have solved the problem, right? And if you still find it little, we can say puzzle, let me see what happened is. Alright, so if you find it difficult, then you can write in the comment section. But I will definitely say you, once you will watch this video again, or either you will try to, I will say first do the code, right? Whatever you have learned, just try to write the code. You have to first think, let me summarize this so you will have a better idea. We have to find this thing first of all, and we can use using a loop, we can find this. And after that, we have to find the last kth node, and which can find by using this pointer, right? this pointer and this pointer. Once we find these two nodes, we can swap them. So this is the simple, we can say, the logic. In just one word, find the first kth node, after that find the last kth node using the first kth node, and after that swap them. So now guys, once you understood this problem, let's move to the implementation part, right? And guys, I would say that don't watch this implementation part if you haven't tried by yourself. So first try by yourself, then move to this implementation part. You can pause this video, right? So let's see the browser where we have this problem. So guys, here we have this problem, certain nodes in a linked list. First of all, I'm going to do, let's say, with this C++. After that, we'll move to Python, then we'll move to the Java. Right? You can move to that particular part. I have mentioned the timeline as well. So it's, if you want to see only Python, then you can move to Python. If you want to see Java, then you can see the directly Java, right? What I'm going to do is, okay, what I'm going to do, I'm going to say, first of all, let me create a current. So this node current is going to be nothing but pointing to head right now. And let me make it size bigger, right? So now you could see, I hope it is visible to you. So what I'm going to do, I'm going to say this, what I can do, I can say first of all, find a first kth node for int I is equal to 1, I less than k, and I plus plus, right? So I can say current should be equal to current next, current should be equal to current of next. Once this is done, what I'm going to do, I'm going to say store in a new variable, right? So this node, I can say first node should be, first node should be current. Once this is also done, so we are going to try to find as last kth node. We can say kth node from the end, right? So for that, we are going to use a new variable, that is, let me declare here only list node. Okay, let me declare new line list node. We can say, but we can give a name new current, right? And this should be equal to head only. And now we can use a while loop, while current of next is not equal to null. You have to keep moving, right? So current should be equal to current of next, and new current also should be equal to new current of new current, right? Okay, new current of next. Once this is done, once this loop will over, we know that new current will be pointing to the last kth node, right? And first node we have already stored, right, which is the first kth node. So what we can do, we can just swap them, right? So we can say swap first kth node. So let me add first node, and we can say new current node, right? And we know that this is not a function, so let's declare a function this thing, and this is not going to return anything, and the name is swap, and we can use a list node, and here we can say first list node second. Let's keep it like this, and after that we can say third variable time, which is equal to first value. All right, now first value has been stored somewhere, so we can use first value somewhere. We can say first value should be equal to second value, and second value now should be equal to temp. Fine, this is a simple swap function. Once this is done, we can return our head. And I hope this is a simple questions, oh sorry, simple implementation, and it should pass, right? I got a compilation error. Why? Let me see. Okay, first I have used a miss character. Why is it so fast, right? And I hope it should not give error right now. You can see both the test cases are passed. So if I make a screen bigger, so you can see, guys, right? Both the test cases passed. So let's try to submit this code. And I believe it should get submitted. And here we go, guys. It's successfully submitted. All right, streak also. Fine. Now what we can do, we can say, let's move to the second programming language, that is nothing but Python. And in Python, we are gonna do a bit of fast. So what I can do in Python, I can say first of all current should be equal to head, and we can say for I in range of 1 to k plus k, and we can say current should be equal to current of next, right? Fine. And once this is done, we are gonna say first node should be equal to current, and let me write here only first node and new current should be equal to, first node should be equal to what? First node should be equal to our current, and new current should be equal to head, right? Now we can say while current of next. So we can not use this curly bracket. We can say while current of next. We can simply say current should be equal to current of next, and new current should be equal to new current of next. Once this is done, what we can do, we can say we have got our new current, which is the last kth node, and the first node, which is the first kth node. We have to swap them. So what we can do, we can say new current dot value, and first node dot value should be equal to, so now new current value should be equal to first node dot value, and first node dot value should be equal to new current dot value. Now once this is done, what we can do, we can say return our head. So this is the easy one, right? Let's run this code, and hopefully I should not get any error. Let's see. You can see that both tasks pass. So let's try to submit this code as well, and I hope it will also get submitted. Why it is, yeah, that's done, right? Now last programming language, that is nothing but Java, and yeah, we are gonna take a little time over here. So what we can do, we can say list node. So let me do first of all like this. List node of current which is equal to head, and after that we're going to use a for loop for int I is equal to 0, not 1, I less than k. Why I'm using 1? Because we are starting a 1 indexes, right? You can see in the question the list is 1 indexes. Alright, so we can say now current should be equal to current of next. Once this is done, we are going to store this particular thing in a variable which is first node. So list first node, and which is nothing but we can say current, and after that we're going to say list node which is new current, which is equal to again head, right? After that we can use a while loop, and this while loop is going to do nothing but while current of next is not equal to null. So you have to keep moving, right? You can say current should be equal to current of next, and new current should be equal to new current of next. Once this is done, what we are going to do, we are going to say we have got a first node and last get node. So we are going to swap them. So we are going to make a function swap. We are going to pass a first node, we are going to pass a new current. Once this is done, we are going to return our head, and let me make this function as well. So what I'm going to do, I'm going to say let's see a void and void swap, and here we are going to say list node. Let me write a node. This is first, and list node, this is second, right? And here we can say first, let's use a third variable in temp. By the way, you can use a different swap as well. So I'm using a third variable swap because I have like find it easy. So now what we can do, we can say first of value, and now first value we can use a second value, and second value now we can use a temp value. Now was not temp value or temp actually, right? Now once this is done, we are gonna run this code, and let me find here semicolon, otherwise it will give me error. And I don't want to get an error in Java programming language. Basically it hurts more, right? And hopefully I got it. In temp is equal to first value, again the same first mistake, typo error. Where is first? It is first. All right, let's see now. Okay, yeah, right. Case 1 and case 2 both pass. So let's try to summary this code as well. And by this programming language, we have done both all C++, Java, and Python. And guys, if you like this video, don't forget to hit the like button. And if you did not understand any of the things, you can write in the comment section. I'm always there to help you. So that's all in this video. I hope you understood something. If you learned something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.